Hello. Good morning.
Good morning, sir.
Okay.
Good morning,
Sorry. Okay. Right. Is whatever I wrote is that visible? The basic system models chapter name
Yes, sir.
is visible, right?
Yes, sir.
Yeah. Okay. Right. Now we'll move on to this particular chapter, okay, which is called as the basic system models. Okay. Now, what do you mean by basic system models is important. Okay. Basically, in this chapter, we are going to discuss what are going to be called as the mathematical models first. Okay. Mathematical models. Right. Now, when we say mathematical models, okay, what is the work that we are going to do here is important. Okay. So please understand this chapter. Okay. It is a bit different. Okay. Now, the objective of this chapter is for determining how the systems will behave. Okay. How the systems will behave. Yeah. Oh, ಇಲ್ಲಿದೆ class. Sorry. ಇಲ್ಲಿ ಇದು ಬರಲ್ಲ ಅಲ್ಲಿ ಬರುತ್ತೆ. Okay, now here, okay, in this chapter, okay, you can able to understand how the system, how the system is going to behave. Okay, how the system is going to behave. Okay, now this is the first thing. Now, what is that you are going to carry out here is, in case of the system, you are going to give the disturbances. Okay, with the presence of the disturbances, how the system is going to behave is what is that we are going to understand in this particular chapter called as the basic system models. Okay, I'll repeat again. The objective of this chapter, okay, the objective of this chapter is to determine how the systems behave with the time. Okay, how the systems behave with the time when subjected to some disturbances. Okay, right. What do you mean by disturbances means? Okay, the meaning of disturbances is nothing but what is called as the forces. Okay, the meaning of disturbances is called as the forces, right? Okay, right. Now, just a second. ಬಂದಿದ್ದಾರೆ ಅಂತ. Okay, right. Now, the behavior of the system. Okay, now here we are going to analyze the behavior of the system with respect to the time. Means now you have a system. Okay, you have what is called as a system. Okay, now to this the time pattern. Okay, with what is called as the disturbance. Okay, now this is what is that we are going to carry out. It is we will be having a basic system and the behavior of the system with respect to time in the presence of the disturbances. Okay, then what is the meaning of disturbances here is important. The disturbance here is nothing but what are called as the various forces that is going to be acted upon that. Okay, now in order to understand the behavior, we require what is called as the mathematical models. Okay, we require what are called as the mathematical models are going to be required. Okay, now what do you mean by the mathematical models are nothing but, okay, what do you expect in mathematical models to be? What do you expect it to be? Just gonna give something. What do you mean by mathematical model here? What are you going to have in the mathematical models? Okay, what is the mathematical model of a straight line? Okay, we'll come to that level. Okay, what is the mathematical model of a straight line? Hello? Are you all there?
Yes, sir.
Yeah, what is a mathematical model of a straight line? How will you represent a straight line mathematically?
Sir, y is equal to mx plus c, sir.
Okay, y is equal to ms plus c is the representation of a straight line equation. Okay, that is what that represents the mathematical equation of what is called as your a particular entity. Okay. Now, what do you mean by mathematical model basically? Okay, meaning of mathematical model is nothing but what it should consist of. It should consist of what is called as the equations. Okay, what this equation to do? Okay, this equation this should describes, correct, the relationship between what, between input and output of a system. Okay, right. Now you know in the first class itself we have done what is called as system. Okay, to the system we have what is called as the input and you have what is called as the output, correct. Now the relationship between input and output, okay, is represented by the equation. Okay, this is nothing but what is called as the mathematical model. Okay, right. So this is the first thing that we need to understand. Okay, right. Now, in case of this, basically, okay, so we'll be having a system. That system may be anything. Okay, that might be a various different systems which are going to be present. Okay. Now, in order to represent that particular system, okay, in order to represent that particular system, we are going to make out the relationship between the input and output. I'm repeating again. Okay, in order to make out the relationship between the input and output, we are going to make the mathematical relationship. That mathematical relationship will represent the behavior of the system with respect to the time with the presence of the disturbances. Okay, now this chapter is all about representing the system in the mathematical means. Okay, this chapter is all about representing the system in the mathematical means. Okay, now you come to the mechatronic system. Okay, in the mechatronic system, what are the basic models that you can come across? Which are the basic systems that you can come across to build up a mechatronic system? Can you name? Which are the basic systems required to build the mechatronic system? What should be there? What are the different types of system? What are the different types of systems? First chapter. Tell me.
Measurement system.
Huh? Before measurement system. Good morning. Before measurement system?
Open loop system, closed loop system, sir.
No, that is about the control system. Okay, I am talking about the basic systems. Okay, very starting I told. Okay, systems are classified into
conventional.
No. Go back and check. Systems are classified into two cases. One is the
Pure and combined.
exactly. Okay, one is called as the pure system. Other is called as the combined system. Okay, which are the pure system?
Both input and output are same.
Okay, no, that means what? So pure systems are nothing but you will not be having the conversion. Okay, means it is going to be the individual system. That means it's going to be what is called as mechanical system, electrical system, pneumatic system, thermal system, or hydraulic system. Okay, right. Now, whatever we are discussing now, okay, this chapter, okay, are you understanding the points? Are you understanding? Hello.
Yes,
Yes, sir.
The points what we are discussing now. Okay, the points what we are discussing now. Okay, let's go to the next second page. Okay, once again. Okay, right. The points what we are discussing is with respect to what are called as the basic system. Okay, right. In basic system, okay, as we know that we will be having mechanical, electrical, correct? Mechanical, electrical, and then tell me hydraulic, okay, then pneumatic and thermal. Okay, now these are called as what? These are called as the basic system. Now the mechatronic system, okay, is going to be made out of these particular system. Okay, in this particular system, we are going to call this as what are called as the, sorry, okay, so there is some issue. Okay, basic system blocks. Okay, now these are called as the basic system blocks. Okay, now one by one we'll try to understand the different system blocks. Okay, right. Mechanical, next one is called as mechanical system building blocks. Okay, right. Now we'll just go one by one. Okay, now which are the mechanical system building blocks? Okay, now that means to say, if you consider a mechanical system, okay, how are you going to represent a mechanical system? Okay, right? The building blocks are nothing but, please understand carefully, the building blocks are nothing but those are the elements. Building blocks are nothing but those are the elements which are going to be used to represent a mechanical system. Okay, those are the elements which are going to be used to represent a mechanical system. Okay, now in case of mechanical system, the models which are going to be used, to represent the mechanical system will have the basic building blocks like, okay, what are going to be called as, the springs, next dashpot, next what is called as the mass. Okay, now these are the three different building blocks which are going to be present. Okay, these are the three building blocks which are going to be present. Okay, right. That means to say, what I am trying to say is, any mechanical system you can represent by using these three systems. It is springs, dashpot, and mass. Okay, right. What springs represents? Just tell me what springs represents.
Damp.
Springs. What springs represent?
Stiffness.
Yeah, tell me. Correct. Tell me. What is that?
Stiffness.
Stiffness of a system. That is, springs represent the stiffness of a system. Okay, right. Okay. Dashpot represents what?
Frictions.
What in the dashpot?
Friction.
Frictions.
Frictions.
Dashpot represents friction, or is it dashpot represents friction or what? Are you telling me that?
Damper.
Damper. Okay, it is not representing. It is not representing
Friction.
It's not representing the friction, but it represents the damping coefficient. That means, okay, it is the resistance against what? Forces. Okay, now basically dashpot is nothing but when you are going to apply a force. Okay, just assume, okay, generally in all the vehicle or in all the systems we will be having, if you are going to apply a force, okay, if that is going to be not resisted by any of the forces, you say that the damper will become completely weak. Okay, if the damping is not going to be there, what is going to happen? If the damping is not going to be there, you will not get anything called as the cushioning effect. Okay, so dashpot represents what? Dashpot is the forces which oppose the motion. Okay, the dashpot represents the forces which oppose the motion, that is the frictional or the damping effects. Okay, then what mass represents? What do you mean by mass?
Inertia.
Okay, mass represents what is called as the inertia. Okay, R. It is also called as what? Okay, let's assume that there is a mass. Okay, right. Now, what is that mass? Is nothing but a lumped a body, correct? No. Okay, let's assume ourselves. Okay, ourselves is what? A fixed entity. Okay. Now, if it is going to be a force is going to be applied, okay, what is that I am going to do? What should I do? Okay, let's say there is some force. Okay, I am going to push you. Okay, if you are not going to move, okay, what does it mean?
I have resistance.
Yeah, you have resistance. Resistance against what?
The force.
Applied force.
Against resistance against the force. Okay, now you know F is equal to equation. F is equal to
MA, sir.
M into A. Okay, F is equal to M into A. Force is equal to mass into acceleration. That means what? If there is going to be a mass, okay, upon the application of the force, if we could not able to dislodge that mass, okay, it means what? There is going to be a resistance to acceleration, resistance to movement, resistance to acceleration is going to be present. Okay, right. Now, these are all the three building blocks. Okay, springs represents the stiffness. Okay, dashpot represents the resistance against the viscous force, or it is the frictional resistance, or it is the cushioning effect. The mass represents resistance to the acceleration. Okay. In all these cases, okay, in all these cases, what is the input that you are giving? What is the input?
Force, sir.
Huh?
Force.
Force is the input. Very good. Okay. In all these cases, you are going to give what is called as the force as the input. Means you are pulling the spring, you are applying the load on the dashpot. Okay. Or you are applying the load on the dashpot, or you are trying to move the fixed mass. Okay. So now, if all this is going to be the input, what you expect the spring to be? Okay, by the application of the force, what you expect the spring to be? You want the spring to get elongate. Yes or no? Correct or what? You want the spring to get elongate. And the amount of elongation, you call it as displacement. Okay. So you want the fluid to compress. Yes or no? In case of dashpot, okay, in case of dashpot, now you take an example of a bike. Okay, in your bike. Now dashpot means what? You want the fluid to get compressed. Again, the displacement is going to occur. Okay. If it is going to be a mass, okay, some 10 kg of load, okay, if you apply the force, you expect the 10 kg of the force to move a bit. Okay, now from the initial point to the next point, what is that you have called? You have called that as what is called as the displacement. That means to say, in all these cases, okay, in all these cases, what is the force? In all these cases, what is the input? What is the input? Input is nothing but the force. Okay, the output is nothing but what?
Displacement.
Displacement. Okay, right. Okay, right. Now actually there is some problem with the positioning actually. Okay, I could not able to exactly match the positioning. Okay, the pen is not exactly giving me the proper position. That's why here and there it is happening. Okay, don't worry about that. Okay, right. Now these are the basic thing. Okay, now means to say, what is the concept here is, if you consider, okay, if you consider any mechanical system, okay, any mechanical system can be represented by using these three basic system blocks. Okay, any mechanical system you consider, it should supposed to have a stiffness, it should supposed to have resistance to the friction, and it should supposed to have resistance to acceleration. Okay, so these are the 3 points. Okay, these are the 3 points which are going to be present. Okay, right. Now, next thing is we'll just go with one by one and we'll try to understand the concept of this. Okay, right. Then we have what is called a spring. How to represent the equation of a spring? Now we'll try to represent the mathematically these 3 different parameters. Okay, right. How will you represent the spring? Okay, assume this is going to be a force. Okay, right. Yeah. What is the equation of the spring? Okay, which is the system here? What is the system? Tell me, which is the system here? Spring is the system. You have input and you have output. Okay, what is the input? Tell me.
Force.
Force. Okay, right. So what is going to happen if you apply the force to the spring?
Displacement.
Okay, the spring is going to displace. Okay, so there is going to be a displacement of the spring by an amount equal to x. Okay, output is nothing but what now? Output is nothing but x. Okay, right. Now, what is the equation? F is the amount of load that you are going to apply is proportional to what is called as the displacement. And this displacement is going to be, the proportionality constant will be equal to what?
K.
K into x. Okay, right. Now, F is equal to K into x. Okay, F is equal to K into x is the mathematical equation for the spring. That means the stiffness of a spring is going to be described by the relationship between the input parameter F, okay, right, which is applied for the purpose of expanding, okay, the spring. And due to the application of this force, the output is going to be what is called as the expansion. Okay, so expansion is going to occur. That is the amount of expansion, you call it as what is called as x. Okay, right. And this is going to be represented as F proportional to x, and this proportionality constant will be called as the K. Okay. Now, what is if the value of K is going to be greater? Okay, what does it mean? Stiffness is large. What do you mean by stiffness is large? What is the greater value of stiffness means to the spring? Just general questions I am just into. Okay, what is the meaning of higher value of K? Tell me, what amount of force is required? Less amount or more amount?
More.
Okay, stiffness of the spring is larger. Okay, the stiffness of the spring is larger means it is the resistance against the extension is more. Yes or no? If the resistance is going to be more, then the amount of load that you need to apply should be larger. Okay, that means more the stiffness, bigger the value of K, the greater the amount of forces, okay, to be used, okay, in order to get the output. Okay, therefore F should be greater and x is going to be correspondingly you are going to get the value, okay, for the higher value of the K. Okay, now second one is called as what is called as the dashpot. Okay, right. Now dashpot means what? Basically dashpot is nothing but, okay, if you just observe, okay, so okay, right, just a small diagram I just like to make. Okay, right. Now this is the amount of force. Okay, now okay, you have fluid. Just a minute, okay, just getting it very hard to write here because the positioning it is not taking properly. You have a fluid here, okay, then the opposite is called as your resistance. Okay, right. Now just observe. Okay, in this case, okay, what we have is, now this is an example for a dashpot. Okay, so dashpot represents the amount of forces experienced when you try to push the cylinder or the piston against what is called as a fluid. Okay, that means what? There will be what is called as a fluid. Okay, so when you are going to push the object against the fluid, okay, against the fluid, what is going to happen? Okay, if there is more resistance, okay, if there is more resistance, what does it mean? What does it mean? The cushioning effect is going to be better.
More.
Huh?
More.
The cushioning effect is going to be better. Okay, that is, there is more amount of resistance. That means what? The push will not going to occur. Okay, now with the application of the force, okay, in the seating, whenever there is going to be some if you crossed a hump, whatever it is, okay, if you are not going to come below, okay, if you are not going to come down, okay, it means what? Now the resistance offered is going to be greater. That means what? Okay, now if there is just a simple thing, when I'm going to apply that in this example, you just observe, if you apply that load onto that object, if there is larger amount of fluid comes out, okay, escapes, what does it mean? You have a fluid, right? Okay, you are pushing against the, I could not able to show that on diagram, okay, because of some issues with here, okay, right? I'll just change the pen, okay, right? Now, if you are going to apply a load, okay, if more amount of fluid comes out, okay, what does it mean? Does it mean resistance is less or resistance is more?
Resistance is more, sir.
No, if the resistance is more, understand carefully. If the resistance is more, can I push the object deep?
No, sir.
No. If I could not able to push the object deep, can I get the fluid to come out because of Archimedes principle?
No, sir.
No. When the fluid will comes out of this area?
If it has less resistance.
Okay, when it has less resistance, the movement of the object is going to be faster. Yes or no? If the resistance is going to be lesser, the movement of the object or the movement of the, let's take an example, simple example of a piston and cylinder arrangement only here. Okay, right. I have a cylinder. Cylinder is filled with what? The fluid. Okay, oil. It has been filled with the oil. I am pushing the piston. Okay, when I am going to push the piston, if I push the piston freely, okay, if I could able to push the piston freely, okay, it means resistance is not much. Okay, at that moment, what is going to happen? The fluid will escape out. The fluid will escape out from the cylinder. Okay, now this is the basic concept of what is called as the dashpot. Okay, in this case, the dashpot building block, okay, represents the type of forces. The dashpot building block represents the types of forces experienced when we try to push an object. Okay, type of forces experienced when you try to push an object against the fluid. Okay, against the fluid or against the frictional forces. Okay, now the more faster you move, okay, more faster the object is pushed, the greater becomes the opposing forces. Okay, now in this case, what is going to happen is, okay, the F is proportional to what? Basically, what is very important. Okay, now F is proportional to what is called as the V. Okay, V is nothing but what here? V is nothing but the velocity of the piston. Okay, now in the case of a frictional resistance, or in case of a dashpot, in the case of a dashpot, the F is proportional to V, where V is the velocity of the piston. Okay, if I am going to take out, okay, if I am going to take out that constant, F is equal to C into what is called as V. Okay, what is C here? What is C? C is a constant which is called as, C is a constant which is called as the damping coefficient. Okay, right? The damping coefficient. Okay, now F is equal to what is called as C. V can be, how you can express V in terms of displacement? How can you express V in terms of displacement?
dx by dt.
Okay, so it is rate of change of displacement with respect to the time. So F is equal to C into dx by dt is what is called as the dashpot. Okay, right. Now this represents what is called as the input, and the input with respect to F, and the output with respect to what is called as the X. Okay, so this is about the dashpot. Means to say, right, in case of dashpot, now the damping or the resistive force, okay, damping or the resistive force, F is directly proportional to the velocity V of the piston. Okay, so F proportional to V, proportionality constant is going to be equal to C, which is the damping coefficient. Okay, V can be expressed as rate of change of displacement with respect to time, that is C is equal, F is equal to C into dx by dt. Okay, right. Then we will take the last one. Okay, so what is called as the mass. Okay, right. Now in case of mass, you're going to apply the force, and then you are trying to move. Okay, so that is called as the acceleration. Okay, right. When you make it to move, what is going to happen? So this is the next movement. Are you understanding? So this is the next movement. Okay. Therefore, from this point to this point, we call it as what is called as the axle. That is, you have moved the mass, okay, by certain distance. Okay, you have moved the mass by certain distance. Okay, the mass building blocks. Okay, so the third one is called as the mass building block exhibits the property that if there is going to be larger amount of the mass, more amount of force is going to be required. Okay. So now F we know that what is called as F is equal to F is proportional to, okay, let's just say F is proportional to A, and if I'm going to take out the constant, F is equal to M into A. Okay. So what is V? V is called as dx by dt. Okay. So we have displacement. You give the push to the displacement, you're going to get velocity. Then the acceleration is nothing but what? Acceleration is nothing but what is acceleration?
d square x by dt
Okay,
square.
d square x by dt. Okay, right. Now we know force proportional to acceleration. Force is equal to m into a. Okay, right. A is nothing but what? A is nothing but change of velocity by distance. Okay, now F is equal to m into a, that will be equal to m into, okay, dv by dt. Okay, so what is dv by dt? Dv by dt is nothing but, okay, v is nothing but what? M is equal to d by dt of v is what? V is dx by dt. Okay, so what is this now? Okay, so it is force is equal to m into d square x divided by dt square. Okay, so m is equal to d square x by dt square. This is the equation of the force. Okay, right. So these are the three equations which are going to be considered. Okay, right. Now I think I'll just stop at this stage. Okay, I'm not so comfortable with the usage of this pen today. Okay, right. So we'll take. I'll continue the class in the third hour. Okay, right. Okay. So sorry for the disturbances. Right. Okay, 1 2 3 4 5. Okay, right. Okay, so I will take leave. Okay, so I will just take the class at the third hour. Okay, right.
Thank you, sir.
Thank you, sir.
may hang out